All right, everybody, welcome. It's 11, so we're going to go ahead and get started. Thank you so much for joining us for this morning technical session. This is a Utility and Engineering and Surveying Institute technical session, or UESI. And today's presentation will be on ASCE 3822, Standard Guideline for Investigating and Documenting Existing Utilities, updates from ASCE 3802. And it will be presented by Joseph Murphy, who I will introduce in a second. But first, I did want to mention that this meeting is hosted in person and virtually. So for our virtual attendees, we will be keeping an eye on the chat. So please, if there are any technical difficulties or if you have any question that you would like to ask in the Q&A that we will have afterwards, please go ahead and post that in the chat and we can read it out during the Q&A. And so now I'll go ahead and introduce Joseph. So Joseph has been working with utilities for almost 30 years, with the last 22 years dedicated to subsurface utility engineering. He graduated from Louisiana Tech University with a Bachelor's of Science in Civil Engineering. He holds PE licenses in Louisiana and Texas, and he's a past president of UESI Texas and currently is the Utility Investigation Chair for Buried Asset Management Institute International. And he is also serving as our ASCE Dallas UESI president this year. So we're very excited to have him on the team and also to have him presenting this morning. So I will turn it over.
Thanks, Amanda. So today we're going to go over some definitions and things at the beginning, which are a little bit boring, but I thought I'd start out with, why do we need SUE, and part of, why do we need to investigate what's in the ground. In this picture here, the only thing you would see from the surface is just this lid. If we hadn't actually opened that lid and looked down inside of it and just said, oh my gosh, there's this huge vault that's there. The records were from back in 1970. It had a square, it had two lines going one way and one line going the other way. And that was what we have for our as-builts. But without doing a little bit of further investigation and then determining, hey, we need to really do a lot more, because there was a flyover that was coming through here and drill shafts were going in. This is something that we needed to use LiDAR and some other information to help build an image from the surface down to what's underground. There's like a huge vault, and part of the newest standard actually addresses the vault details and the information that we need to collect from those. So this is just a little segue into today.
So where was it? Is that here?
That's actually the DFW Airport. So there was an old standard that came out in 2002. It was a whole 13 pages. It didn't address a lot. There was a little bit of an appendix. Back then in 2002, there wasn't 3D or a lot of the other technologies that we had. GPR was still fairly new, and there's obviously a need to update as things were progressing. It took a little while before the 22 came out. It's much larger. Now it's up to 90-something pages of the actual content that's in there. A couple of things they added was some commentary, other like examples of how to apply the different quality levels. They did update a lot of definitions, which we'll kind of go through as well. And then they added overhead. So before it was strictly subsurface. Now they did add an overhead component for the whole entire utility network that's involved with it. And that's why they took out the subsurface piece of it, and they just said utility investigation, and then the documentation of those. So what's different? There are some new terms, some things that weren't addressed before are now being added. So there are some new type of language that we're going to be using. We're going to update some of the old definitions to the newer ones. The actual term SUE has a new update, or updated a couple of years ago. As I mentioned, aerial is going to be included. Performance goals. So what do you need to achieve to get a quality level? What's your goal of what do you need to achieve to say, yes, this line is a certain quality level? Vaults, as I kind of mentioned when we first started. The utility report. A lot of times we'll add a lot of lines or notes to our plans, but now there's a supplemental guideline for documenting any of that other information that you want to add about a project to that can supplement your actual design plans. Electronic depths. Those come up a lot. Everyone's usually saying, hey, how accurate is that? We'll look at that and talk about that some more. The standard does now it starts to address the 3D model. It hasn't gotten there yet. The actual 2038, 27, which is going on in a few more years, will have a little more information on the 3D model component of that. And then some commentary. It actually has some little examples of, hey, is this level B? This is level B. So it gives you some examples to what to look for whenever you're doing that. So SUE, as I mentioned, SUE included a lot of things before. It had design, it had utility coordination, construction management. Now they've kind of condensed it down into what do we think SUE is? SUE is actually going out and finding the utilities and then surveying those and adding them to a utility map. So that's what they did when they did a survey and said, hey, what do we really think SUE is? It's not all this stuff, it's really what we think it is. So it's a specialty practice of civil engineering, utility engineering branch that includes investigation, analysis, judgment, and documentation of those existing utility networks. And a utility network is the piece that goes from the underground even to the overhead. So it's the entire system itself. It's not just what's underground. Then the judgment piece, we'll talk about that a little bit later on when you apply a quality level, what judgment goes involved with doing that. Anchor point. Anchor point's one of the new terms. Those are the different features that are involved with our investigation. Those anchor points are now going to be surveyed, and there's a certain accuracy that needs to be associated with that anchor point. Usually that's going to be involved with the quality level. If you have 2 anchor points, and now you have 2 solid points that you can use to develop the utility segment. So that segment is a continuous line. If you're marking it, tracing it, or have a record, there's a certain little segment. Just because you're on one line doesn't mean that entire line's a segment. It's only the piece that you're able to actually validate through either geophysics or other pieces of information. Designating. A lot of times when you say, hey, I need you to go locate that line. Well, locate we'll talk about next, but it's actually designating is what the field guys are going to go do when they go out with their piping cable locator, GPR, acoustic, those type of things. So it's the application and interpretation of shallow earth geophysics method to infer, with or without surface markings, the existence and approximate horizontal position, when possible, and part of the scope of work. Depth of the subsurface utility segment and/or utility feature. So it's not quality level B just because a guy goes out and puts paint on the ground and marks it. We'll talk about how it becomes quality level B. So locating. Again, locating is when we actually go out and we expose that utility. It's not the guys that are actually marking it. So when you see a vac truck that's out vacuum excavating a hole, that's going to be the locating piece of it. When you're actually exposing it, you're gathering the different information about that. Verifying the utility determined is the function, type, position, and outside diameter of the observable attributes of that existing. So sometimes you have a duct bank that has corners of it. You should be exposing at least one, or if not both of those edges, so that you're exposing the entire piece of that. Again, this is not quality level A just yet, once you have that data. So how do we make it quality level A? It's assigned once an engineer has actually reviewed that data. So we're looking for, what do we find? Okay, there's a pipe in the ground, it's yellow, and I'm looking for a communication line. Is that the pipe that I'm looking for? Probably not. But again, until an engineer reviews that data and determines that that's the pipe that you're looking for, can that line become quality level A? The other component of that is a survey component. The vertical now, it used to be 0.05. They have lessened that a little bit up just to 0.1 for the vertical and then the 0.2 for the horizontal. If we can't achieve those values, then we can't assign that value of quality level A to that test hole, to that location that we're looking for. Quality level B, the value assigned to the utility segment of surface feature whose existence in horizontal position is based on geophysical combined with professional judgment again, and is tied to that survey data. So when do we assign it? We found some kind of form of method to say, yes, there is something there, some form of geophysics, GPR, pipe and cable locator. Signal was reliable. So if your field staff, hopefully they're trained and understand that if they're just because they're on a signal, they're getting a tone on the line, doesn't mean that that's the line that you're looking for. It could stray off and bear off, back and forth in what we call bleed over or, signal interference. We actually ended up having a study on that a couple of years ago because We were putting a fence in the backyard of our office, and the guys, when they marked it, we've got a water line, we've got a telecom line. Well, the telecom line started meandering over toward the water line, and it meandered back. Well, did it really do that, or was there some kind of signal interference? So just because the guys marked it doesn't mean that that's necessarily exactly where that line is. So it's the interpretation of that data once you get it and review it, and then look and see if it is valid. Interpret the position of it. So it's the knowledge of the geophysics. Field staff use those different pieces of equipment, but do you understand what they're gathering when they use that piece of equipment? So it's good for us as engineers to understand that, yes, okay, I understand, but I need to make sure I have a good ground. I set up my pipe and cable locator. Is it in the correct position? Am I on the right frequency that I should be using to mark that certain kind of line? And you can ask these questions if they're not finding things in the field, and that way you have a better understanding of what kind of data that they're finding and giving back to you, because you're the one that's ultimately going to sign and validate that data. Does it make sense what the line's doing? With horizontal directional drilling, yeah, those lines can do a lot of different crazy things. But if I've got a 24-inch steel water casing, it's probably going to be, fairly level, with minimal grade, but also very straight. It's not going to do a bunch of crazy little meandering. So if I'm getting a line that's showing that it's going a bunch of different directions, you might want to revisit that data that you're getting, because it's probably not in the right spot. So understanding how that line should be installed helps you determine if the data is valid. Records, if they're available. Found it here, records show it's over here. Which one do I assume is right based on surface features or other findings that are there? So correlating those two together to see which one may or may not be correct. And even surface features, if you have valves or telephone pads, manholes, things like that, those can be good clues as to if you're in the right spot. And I'll show you an example here of why you can't necessarily always use the visible features that are above ground, because they can be deceiving. Is it all tied to the project datum? If it's not in the right spot, the data is no good if you shift it another foot or two off, or use grid instead of surface, and the project's in surface. So making sure that you're in the correct datum and that you're tied to that datum with a 0.2 horizontal accuracy. Quality level C, this is where that anchor point comes in. To achieve quality level C, you have to have 2 anchor points. And then between that, you'll have that segment that's in between those two anchor points. If you just have a water valve and the line that's going away from it, that's not quality level C. You have to have those 2, and those 2 have to be surveyed to that 0.2 accuracy between those 2 before that quality level C can be achieved. That's why a lot of times you won't see a lot of quality level C versus quality level D, because it's just hard to achieve that actual requirement. And then D is everything else. You've got records, there's something there, but you can't find it with the surface feature. The geophysics isn't working, you can't find the line there, but you do have a record of it, or somebody said, yeah, I've got a line right here. More than likely you need to make sure you put that line, that line in your plans, because ore recollection is part of level D. And there is something there that we need to maybe investigate more, and that can go in the utility report that says, yes, I need to do some further investigation, whether it's exploratory, vacuum excavation, or something else. That could be part of the utility report that, hey, I know there's something there, but I just don't know where it is. And if it's important to the project, then we need to look at it some more. And then in that utility report, again, this is kind of that catch-all. Obviously, it's a risk assessment on our end of, how am I going to protect myself? Because sometimes you don't know what the scope of work is that the information you're being provided is. If you're only asked to do one side of the road, and then you get a set of plans back, and well, where's all this data at? If it's not listed on the plans themselves, it could be in the utility report of, hey, this is why I didn't do the north side of the road, I only did the south side of the road. Or I tried to find this water line, I couldn't find it, and these are the things that I used to try to find it, but it's just not there. So there's a lot of little pieces that you can, the right of entry, I couldn't get right of entry to go through an area, so you can document that now, and that's why there's maybe a gap in your data, because you couldn't access a certain parcel of land. There's a lot of little things that we can provide in there. The Dallas district here at TxDOT actually has a piece, a guideline for that standard utility report. they have been requesting those for our future investigations. So there is a guideline that's there. They come in all shapes and sizes, but again, it's just really up to the engineer and your client. So it's a professional's responsibility to clearly state the data constraints and caveats to convey potential risk associated with the existing interpretation and prevent the end user from misusing the data. So if you only did a level D and you're saying that you make sure that's in the report, always only asked to do level D, they take that because it's in MicroStation. Now they're going to use that for design. You probably shouldn't be using level D information for design. So you need to clearly convey that you shouldn't be using this for construction, or additional information should be required. Metadata. Metadata is something that I think has been used a little bit more. So there's a ASCE 7522. We'll probably be doing a presentation on that here sometime in the near future. This is what they call an as installed standard, up to the point. I know Peter's here. So. They capture a lot of different feature codes, and in those feature codes, there's a lot of data that's associated with each one of those pieces of information. It's the size, the installation, the contractor that put it in, material. I mean, everything that you could ever want to know, there's a feature code that can be added. And now with Open Roads, you can add all that data in there and start capturing that. And that information can be used so that instead of having all those leaders and lines all over your drawing, you can hover over a line and get all the information that you need from that, so that those notes aren't stripped away, and you can use the data, pretty smoothly. And then the 75 also able to add for the utility company itself, for them to be able to add that information into a CSV, and even 3D open or 3D civil 3D as well. TxDOT Rulus has a way to start entering feature codes as well. So there's going to be more ways to enter all this in this data and capture and pull it all together so that it is useful for everyone to use all at the same time and over through different platforms. The overhead. So like, again, I mentioned at the beginning, overhead wasn't addressed before. Now it's part of the whole interior utility network. So that line's underground, and sometimes those comm lines come up a pole, or the electric lines come up a pole. So that's part of the utility network, and you need to make sure all those are connected and that we have them labeled correctly so that you have a part of the whole system. Determining who the owners are. A lot of times that can be a little bit tricky in some areas where you're switching between Encore, CoServe, whoever it is at the time. But they usually will have tags, or sometimes you have to track it all the way to where there is something that has that line. Comm are the same way. You've got a fiber that's underneath an underbuild. You're following that comm down, wherever it comes down, and it goes into hopefully a vault or PED. Then maybe from that PED, you can determine who that owner is. Requesting the records. It's even becoming more important. I know that one of the new standards for the Dallas district is the pole's height for records. They want to know how tall the pole is, because you can't see how far it is underground. You don't know if it's going to be 10 feet, 20 feet, or whatever it is. And sometimes with those records, you're able to obtain that data, and when the utility coordinator gets it, they can use that better for a cost assessment with those records. The other part of that is even with the telecom and those, you can see how many different fibers are in there. If you don't have a handhold or something to access it, to see what's in there, at least if they have a record of what they're showing is in that installation, then you're able to replace that if you have to relocate those lines. The pole positions, obviously when you're surveying those, that's as an anchor point, and even the anchor itself, surveying both of those things, because even the guy wire, when it goes in, the guy wire may have some concrete that's associated with it as well. So you have to take that in consideration if you're trying to run any new lines or drainage, things like that next to it. The sag heights, I know TxDOT Dallas, anything that's crossing a road now, you have to have the sag heights associated with that utility plan. You may request it along the parallel piece for sound walls and other pieces that may be affected. The poles are usually at 3 foot. If you want to put a sound wall at 3 foot, well, you probably need to know how tall that sag height is, or if those poles or sound wall need to move because there's not enough clearance between those two. Overhead doesn't have a quality level. You can see it. It's there. There's not really a risk or anything that's associated with it. They just haven't came up with one. So the level D piece, the performance goals, there's like a certain little checklist of items that you might want to look at. Obviously, identifying the owners. You're going to collect as much records as you can. Even if you're looking at a set of water plans and you see a gas line, you could probably use that gas line as part of your record, your level D for gas if you didn't get gas plans from them. So being able to pull those different sets of plans together into one plan is something you can use. Permits are a good one. As things progress with Rulist, the permit system is going to get better and be able to spit out the data to where you can say, hey, yeah, this is good, or I have a general idea of what I should be looking for when I go out to the field. Just because there's a permit doesn't mean it's there. So you still have to validate that that permit was actually installed. Any GIS database, if you go online to Town of Addison or City of Dallas, you may or may not have access to some of their GIS. So you can just obviously pull that information in and use that for level D services. If I see a water meter, but I see a fire hydrant, anything like that, but I don't have any plans for a water, I still could probably assume that there's going to be a water line there somewhere. And if you have enough hours or maybe some other information, you might be able to just make an engineer's guess and then put a note on there that says, based on engineering judgment, I'm adding this water line, just so you know that it's there and we probably need to account for it or maybe do some additional investigation. And it could also be as simple as someone saying, hey, I put in this line, there's a line here from whenever, a homeowner or business, somebody can just come out and say, yeah, there is a line here, even though there's no surface features or anything that's associated with that. And if they are telling you that, then you can't add that as a quality level D until you've done more investigation to see if there is truly a line there. A good sample of that oral recollection on the left was actual mass build that I got from a small town, which is pretty good for them because it's, at least they had it digitized. It wasn't just an old set. Well, they showed it kind of going down the middle of the road. So I drew it in down the middle of the road because that's all I had at the time. Well, once we did our actual level B investigation, there was an unknown line over here to the right of it. That little 2-inch was a 2-inch ductile, and we were able to induce it when we were doing some sweeps and actually found out where that line really, we think that's what it is. I still left it as unknown because we never uncovered it at that exact spot. But then the owner said, yeah, it's going down the line. The same part of that 6 inches tying into that 2-inch. Well, we found out from the water system itself, they're like, no, that water line doesn't go to the end of the road or tie into that old 2-inch. It stops over here at this fire hydrant. So that's where we ended up stopping the fire hydrant, just based on the utility owner saying, yeah, that's where our line stops. So we had some information, we used some records, we used some actual field data and investigation that we had, and kind of put some of that together into a little drawing. Quality level C. It's kind of an upgraded version of level D. You're still not exactly sure where it is, but you've got enough information to know that line exists, and you're able to tie it together with 2 anchor points. If you have any kind of vaults, sewer, or anything like that, if you're not popping those lids and looking inside of them, then you might have a chance to where you can mess up. And here's a really good example of why you open those up. You determine what size that things are and which direction that they're going. Because this is straight out of the standard. So the one on the left is the level D line. I've got two manholes that are surveyed. So now, it's level C, right? Well, I didn't open that lid, but if I open the lid for that storm, well, that line's actually offset. So we were incorrectly drawing that line as level C on the left if we hadn't opened that. So opening those and doing the butterfly diagram or documenting every single manhole that you open, that way you can get the direction and size of how all the things are flowing together. So that's kind of a good example, and it's straight out of the standard of why you open those and how to depict those. By level B, it gets a little more tricky, because now you're relying on field staff, records, and then your own judgment of how that line is put together. Did we use the right type of geophysics to find that line to where we're able to mark it and then survey it to that accuracy as well? So not only do we have to look at that survey data, we need to check it ourselves to make sure that the surveyor didn't have a bust in theirs. Look at their control that we're tied into the right one. But then did the field staff interpret the data that he's finding? I mean, that signal jumps over to another line, and now all of a sudden you're missing a line because the signal was bleeding over. That's for them to determine whether or not they're staying on the same line. So experience is a big part of that field staff and then building that trust with them. But then when it comes into the office, also reviewing that data to make sure everything is where it says it should be. One of the things you can do, so trace wires, this is where that judgment comes into play. Just because a trace wire is kind of wiggling, you've got a gas line that was installed, they just threw in the trace wire on top of it somewhere in the trench. So your line's not going to be not going to be very straight. Generally, when I see data and I know the line's not very straight, that means they probably actually marked the line. If I see perfectly straight lines when they mark it, that always is a little suspect to me when I see field data come in that's perfectly straight, because most of the time things aren't going to be perfectly straight. So that's always a little clue. But what you can do, and I don't do this too much, but that line's probably, it's probably straight. You can use engineering judgment and do what they did at the bottom and actually take that line that wiggles a little bit and straighten out that line and still say that it's quality level B, up to a point, because you still have to have that 2.2 horizontal accuracy that's involved with it. But if you wanted to straighten it out a little bit, they're saying that it's okay to do that. And then the quality level A, this is where we actually expose it. Usually this is the least amount of risk that's involved with finding a utility, but there are certain things, and they did bring it up, and it has actually happened to me a couple of times, and I'll show you an example of what happened. Just because you're digging on a line and you find something, you have to make sure that that's what you were actually looking for. If you're looking for a comm line, you dig up a comm line, you find a blue pipe, it's 12 inches, it's probably not comm, it's probably water. So I still need to go look for some comm. But then you also, if you validate the data with the utility company, this can be a big help to you, and then tying everything to survey control. So what happened, looking for a telecom line, found a telecom line. So great, we found what we're looking for. Send the data to the utility company. That's not my line. My line's actually deeper. We put a trace wire inside the line that's above it. So we had to go back and actually dig a little bit deeper to actually find the conduit the fiber was in. So in this case, it was a little tricky. They put a trace wire in one thing, but then their actual their fiber was down below that. So fortunately for us, we did say, hey, utility company, is this your line? We're making sure everything was good with them. And they knew enough about their own facility that they brought it up to say, no, that's not mine. I only put a trace wire in there. There's no line below it. So got lucky in this case. There wasn't a lot of difference between the two, but again, we definitely would not have met the criteria for quality level A on that test hole had we went with just the trace wire itself. So being able to look out and understand what you're looking for when you do that. Electronic depths. This is a big topic because of 3D. With the building 3D models, you need a lot more data than just in how you collect that data. Electronic depths is one of the ways to do that. This is something that we've been looking at for a while, and we've collected enough data, and I submitted an abstract for the upcoming pipeline conference to do a research project for electronic depths versus actual depths. Because we collect that data on every test hole that we do, or at least if it's tonable. So we have what they call an ED, or electronic depth, versus what the cut is, and they're all over the place. And so our research project is going to be for the DFW area. We'll be presenting that next, I think, August at in Tampa to do that. But we have thousands of points that we've collected, and what we're trying to come up with is when someone says, hey, how accurate is your electronic depth? Be able to have some kind of data that validates or backs up what we're saying. Yeah, it's probably about 10%, or it's within 6 inches. It could be within a foot. It could be a couple feet off, as you can see a couple of these other things. So you just never know. But we're trying to base it on different types of utilities and things like that, so that we can at least talk a little bit more intelligently about it. And the reason for that, the diagram at the top is out of the standard. So you've got different ways that you're collecting data. If you use GPR, you're finding the top of that pipe with the GPR. If it's a bigger pipe, like here in this example, it's 24. So how's that cab tech going to actually draw in that line? You've got data down to the top. Does he know that you're at the top, or is he just going to draw that circle in the middle of that line? So now you're just adding a foot difference or inaccuracy into your drawing by doing it that way, or assuming that that's the middle of the pipe. The pipe and cable locator finds the center of the electromagnetic field. So it's finding that peak signal at the center of that pipe, or trace wire, whatever metallic object that you're finding. So if you don't know how you're collecting that data for that electronic depth, then that way you know where to put your symbol. If you have a sonde, so if you have a sewer or storm line that you're just running a sonde down the bottom of it, that's sitting at the bottom of the pipe versus the top of the pipe. So again, if you got 2 foot, you're almost introducing another 1.5 foot error into that elevation just by marking the sign. And then the fourth thing that they didn't bring up is if you have a crawler. So if you have bigger pipe, you're running a crawler down your storm, that crawler has a sign on it. You're finding that sign. Well, the crawler camber pipe is probably going to come up a little bit. It's not just going to sit at the bottom. It could be up 6 inches or 12 inches. So now it's 6 inches or 12 inches off the bottom of that pipe, and you're finding the depth of that sign that's in there. So understanding how you're collecting all these electronic depths to build your 3D model is very important when you're putting all the data in there, because you're just introducing all kinds of error into your design. And that's why it's always good to validate with either a test hole, especially at critical locations. So whenever you start using 3D models, ask them how they collected it and where did that data come from, because it can throw off everything that you're doing pretty quickly. How were they obtained, and then how will they be used? So vaults are a new thing that was added to the standard. Vaults occupy space. Just because you see a handle out there with a little symbol on it, that's usually not necessarily the actual limits of that vault. So the standard brought up, when you start measuring the length, width, and height of each one of those vaults, because you can't make bad assumptions on how they were depicted and where they're going. Because if you show them in 2D, again, you have like a manhole, you've got a circle, you got a symbol for a circle for a manhole. You're just going to assume that usually it generates out from the, proportionally around it. Can those be used as anchor points? Sometimes. If you open the lid and you validate that that's maybe at the center, or you've got some kind of way to show that at exactly that point, you can draw a line from it, then you can use it. But if you don't open that lid, then you're going to make the bad assumption like before. The segment, yeah. So the segment, the structure I'm trying to get to. This guy. So normally, like I said, this one. You got a symbol, you got a little thing for a handhold that's on your plans. That's what you're normally looking at when you look at a vault. But reality is, if I didn't open that lid and see what was in there, the vault was offset. And this is almost 12-foot wide vault. So if you're trying to occupy some space or do a design next to it, you're probably going to run right through this vault. And this was a huge Verizon vault. This is like a $5 million relocation just for this one vault if they had to move it. So understanding where it is in space and how it sits along with your project is very, very important to document that piece of it. And how do you get this data? There's a couple different ways. You can actually send somebody in there with a tape measure or a little laser and scan it, or you can actually do send a LiDAR and do a scan that way. A little bit safer, and then you've got a little better accurate. We were able to just extract this little wire diagram from the scanner data. So it's not much effort to do it, but it is something we have to start, and the standard does call for it, us to start doing that as providers. And then the report, there's just so much stuff in here. Everything that you can possibly think of. Areas that you swept, that's another one that's, if you can't directly connect to a utility, you have what's called a two-man crew. You're trying to induce a line from the surface. You try to mark that line. If there is something that's conductive that's in between, well, where did you try to find that? So that unknown, unfortunately, our guys did find that unknown by doing that. But if you don't know where you swept or how you swept that data, you still might be missing something. Because depending on the type of pipe and cable locator that you use, which we have to document, some of them only work perpendicular, and there are some that they'll work at that if you're skewed a little bit or if the line's skewed. So depending on which type that you actually use to sweep with will determine how accurate that sweep could be. So you could be off because you're skewed because you're using one that's perpendicular, or you could be better off if you're doing a circle or sweeping an area and you got two that have omnidirectional, so it could be any different way to use that. So something else, again, just the type of equipment. So that selection, they're using GPR. So there's single channel GPR, there's multi-channel GPR, there's single channel multi-frequency GPR. So there's a lot of different versions of that as well. Just because you're going to use GPR, you didn't know, which one you're using and what kind of frequency you're using, because you could get different data depending on the type that you're using. So again, just understanding what's required. The contract, again, just making sure you state the scope inside that utility report so that someone else knows what you are trying to achieve. versus what they think you should try to achieve when you get that data 5 years later or something else, because you might have forgotten exactly what you were asked to do, or if somebody else is reviewing it, you can go look at that and say, okay, yeah, they didn't look for that, so I shouldn't expect something there. This is something that usually almost in all plants now, I know, especially here in Dallas, I mean, you got to have your footage for everything that you do, the test numbers and all the other pertinent data. I mean, those are in the actual plans, but you can also add that to the utility report. Any problems that you encountered, if the line's maybe being very deep or I wasn't able to get a good signal on that line, we can document that now in that utility report. Said, I tried to mark it, I was only able to get it maybe 10 feet, and then I wasn't able to get a signal that was reliable enough for us to use. That could happen when something's very deep, or if you're trying to dig a test hole and you hit rock, and you actually couldn't find that. Just because it's on the test hole sheet, you might want to just document it saying this whole area is really rocky, so I wasn't able to dig up anything because they bored through the rock and I wasn't able to see it. Recommended future work. So if you have a level D line you think it's going to be a problem, but they didn't ask for test holes or maybe some level B, that might be time to suggest, hey, you probably need to take a little deeper look at this in your scope, and the next time you reinvestigate this to find out where this line is, because it's going to be critical. And then all the pictures and LiDAR data and things like that, because those are, picture tells everything, especially inside those vaults. You can see what's in there pretty quick and have a general idea of, I have a big vault, but I may only have two lines in it, or if I have a smaller vault, but it's got, 12 cables in it, then, it'll help you, determine whether or not how important those are, or how much issues you could have with doing those. So the 3D, kind of what I was talking about. So over here on the right, you've got where you dug a test hole. So now you know exactly where the top of that pipe is, and now we can depict that line correctly. They used a little bit of GPR, I think, in that solid segment. It looks like they adjusted it to that test hole. On the right was a piece that was done by pipe and cable locator. The short dashes were the records. And then the other part was the last dash is, I don't have any data. I've got a top of valve and I've got a spot over here from the records, so I'm just going to randomly draw it. So you can see how you can get variations all over the place when you're trying to put together a 3D map and understanding how you've got that data. So what would be great? We look at the world, we put on our VR goggles, and then now we're able to look, and see what's under there. This is where we're trying to get to at some point. If you can do that augmented reality, if you build a good 3D model, you can actually wear those goggles and walk around and see what's underground while you're doing that. That's coming in the future, but it's something we need to start thinking about while we're collecting that data. Some of the commentary, again, like I said, they've got some pretty good examples in here. Stuff that we normally wouldn't think about. If you got manhole to manhole, you've got two good anchor points, survey's good, I've opened them up, yeah, they're going that way. Normally draw that line level C, but could you make it level B? Yeah, if you've got a way to do a light source is a directly straight line. You could probably get pretty close to just shooting in two reflectors. Again, it's a little far out there, but there are some ways to make a line level B in between some of those. That's kind of the example that they were showing. The other thing is fire hydrants, and when we're connecting some of those, I was able to tone a piece of it up to, but then I couldn't get all the way to the fire hydrant. How do I connect that point from where I stop finding a signal to the fire hydrant? What quality level is that? If they're straight and you've got records that show it's going straight, you could probably call it level C, because at the end of that quality level B, you should have a good anchor point, because now you've surveyed to that 2/10, and you can shot the fire hydrant. Now that fire hydrant's at 2/10, you can draw a line between those two. But if that fire hydrant's not directly in line with your quality level B, wherever your quality level B ends versus where the fire hydrant is, you probably got to draw that line level D. Does it look like that? Probably not, but you never know what could have happened in that situation. Another one that sort of happened to me. It's good lesson learned, and I'm glad it's kind of made it to the standard. So you're marking a level B line, you lose signal for a little bit, but then you kind of keep going, and all of a sudden I've got a signal again, and then you lost it. You get to looking around, okay, well, there's a repair patch. So maybe something might have happened. Well, there was a break, and so during that break, they just ran a new, they fixed it by bypassing it and tying back in. So what you might have ended up with, if you didn't pay attention to the cut patches there, you might have just drawn that line straight and called it all level B, whereas the top one's a little more correct because you actually show where those lines stopped. What happened when I was doing it, we had a level B line, we dug a hole on it, found it, exactly what we're supposed to do. It was in the grass, unfortunately for me. So we told the geotech, yes, you can drill 5 feet over, you should be clear, because we found the line that we're looking for. And sure enough, they hit that line because there was a repair onto that line that we dug a hole on that was bypassing. So it can happen. Fortunately, in this situation, it's better because you got a cut patch, something to work with, but those things can happen if you're not. The good thing is that as we're collecting that data from the 75, those repairs will actually be documented, hopefully, in your information, so you know where those repairs are, and you won't run into that situation where you're hitting a repaired line versus something else. So if all those repairs are being documented accordingly and with all the attribute data, then you should be good and you shouldn't be hitting those lines moving forward. Again, most of us will be retired, gone, but for the future and the building these models and the data, it's always good to help record that. And with that, open up for any questions. And this is actually at our office where we merged we did some scans in the ground, the vaults that we had in front of our office, and looked at above and kind of put it all together into above and below.
How do we differentiate abandoned line and
Right now, we're just documenting as a note that says abandoned. Actually, I have that. So like what I did. And the only way we're going to know if it's abandoned is if someone tells us. The pipelines will say not in service because the pipeline, that casing or pipe could be used again. So like on this one, I'll just put 2-inch abandoned. This is kind of how I document it. But if they say it's abandoned, and it's something I believe is probably abandoned, I'll put abandoned, but usually I'll put not in service because I have seen situations where the pipelines will say, okay, yeah, we abandoned it, but what they really mean is they took the gas out of it, but the casing is still there, and somebody else could use that casing use it for a casing. Like a telecom could go back through, or they can decide sell it to somebody and they're like, I want to pump some gas back in here. So the abandoned and not in service are kind of two different situations.
Worldwide's existing record or actually survey?
We'll survey the line if we know where it is. We'll put that in the drawing because you're going to encounter it during construction. So you want to know that if you hit something, okay, yeah, that line should be there but it's abandoned. The new requirement from TxDOT now is to take those lines out completely, like across the board. But it's going to be a long time before that happens. So there's still going to be all those old lines laying around in the ground.
What would you discuss with someone requesting a student on a fairly decently busy corridor where they just want, they may say, I just want level B, C, and D on one side of the road. We know there's evidence of crossings. What would be a good response to someone requesting that and letting them know about the vulnerabilities of not letting your scope at least cover the crossings that go to the side that they're interested in?
So with that, we always say we're going to have to go on the other side of the road. Sometimes we have to go outside because it's part of a utility network at that point where you don't know what's crossing. We still have to do our records research for the other side to see if anything can be or should be crossing. We need to go open the vaults and manholes on the other side of the road to make sure nothing's coming in. It happens a lot when we do like schools, because schools will be like, well, we only want this little piece right here. I'm like, I need to know where all your services come into this because we can't take any risk of those coming in from somewhere else and coming into your scope of work. So it's a holistic thing, that utility network piece versus just you can't be tunnel vision on what you're just doing exactly.
So does the new standard have a section dedicated to safety what are the kind of things if it does? What are the safety considerations?
It doesn't have anything specific to safety, but assigning a quality level is your risk that's associated with that. So, sort of, but there's not one specifically for safety.
Quality level, what quality level would like ROV based data be? Like remote operated vehicles that you would put down systems? What quality level would you think it would fall under?
If we're toning it from the surface, we could probably get achieve level B from that, because usually there's a sign and it has them inside the crawler or snake or whatever you're using. So we're able to mark that line as it's moving along. And usually when we do camera work, that's what we'll do is we'll mark it. I know there's some of the really fancy stuff, the geo balls that you can drop into a water line and they'll kind of reference themselves from the surface, and as they go into a pipe and you catch it, and now it's in 3D. But with most crawlers or snakes, we can usually get level B if it's there. If it's not too deep too, if it's 30 foot deep, we're probably not going to get enough signal, because as the depth goes, your signal widens as it comes to the surface. So that circle, as it gets closer to to the top, is going to flatten out. And so it's really hard to find a peak signal. And so a lot of times they'll say, no, I can't tell you exactly where that line is. So I've got a couple of dates I'll throw out. So as we're getting started with here in the Dallas district, just some upcoming things we have from UASI Texas. We'll be kind of doing some joint stuff with ASCE Dallas, and then even on the national scale. If you want to go to Houston, or you have some folks in Houston, the Texas chapter is having a thing at the end of January, I believe, or maybe it's the 1st of February. They're having their quarterly meeting. I plan on having our first UASI Dallas one in March. With that, we'll be talking about trying to get together the board, other members who wants to volunteer for speakers. The plan for the year would be have 2 utility speakers, 1 survey speaker, and then we'll have a joint meeting with Texas chapter whenever they're here in Dallas. So that'll be our 4 meetings, probably a year, that we'll be looking at moving forward. There is the pipeline conference in Tampa next year. Those are always pretty neat because there's people from all over the world that are there. Hopefully I'll have my electronic depth study completed. I know that paper's due soon. Then we're also having a Texas chapter UESI conference down at Corpus Christi this year. It'll be sometime in May, and I'll be posting all that on the UESI website so that you can see all those different dates.
Just want to add to that, the education committee is putting together a scholarship application for UASI. So the first scholarships from Texas UASI will be awarded during the conference at Corpus Christi. And we're actually going to have 2 scholarships because of UASI involves engineering and surveying. We're going to have a $2,500 scholarship for engineering and a $2,500 scholarship for surveying.
Awesome. So yeah, any student chapters that need some extra cash. Well, thanks for coming, everybody.
Everyone, if that's all, then we can
Time too.
Okay, I could smell the heater and I was like, is that the heater or is that my computer?